class, today we're going to review using a digital topo map. So let me first share my screen. All right, so here is the digital map, and let me zoom in a little bit so we can see some of these features. All right, so at the top, we have the title of our topo map. So US Topo, made by USGS. And towards the bottom, we see our datum that this map is based on. So NAD 83. We also see declination. So in the state of Maryland, we're approximately 10 degrees. We have a 10-degree difference between magnetic north and true north. We also see our scale bar, so 1 to 24,000. So that means every millimeter of the map is representing 24 meters on the ground. We also see our legend, indicating the different colors and shapes, what they are representing on our map. So let's scroll to the top so we can see latitude and longitude. So first, let's do actually a quick review. So in this example, New Orleans is 20 degrees north of the equator and 90 degrees west of longitude. Now on our topo map, not only are we going to see degrees, we're also going to see UTMs. So this is a projection system, and it's nice when you are working with a very narrow longitude, piece of land that has narrow longitude. So for example, a state within the United States. If we're just interested in analyzing something happening within a state, we're going to use UTMs. Whereas if we were analyzing something happening across the entire country or continent, then we would use a different projection system, like an Albers equal conical projection system. But in this class, we're going to be focusing on UTMs. So let's orient ourselves with the map so we understand the differences between using degrees or UTMs. So okay, so here is our example. So let's go back to New Orleans. New Orleans was 30 degrees north, 90 degrees west, and we are 39 degrees and 77 degrees. Okay, so now we also see these UTM numbers. So let me describe what those mean. So 331, this is one example. So this is the easting. So UTMs, they don't say latitude and longitude, they say easting and northing. So this is indicating we are 331 kilometers east of where that 18th zone begins, the 18th UTM zone. And then we also see, and let's also look at 4317. So this is how many kilometers we are north of the equator. So we're 4,317 kilometers north of the equator at this grid line. This grid line right here. And 331 kilometers east of where the 18th zone begins. All right, and then the last three numbers that we tack onto these easting and northing coordinates are how many meters we are away from that grid line. So I'm going to go through an example of our football stadium. So here is University of Maryland's football stadium. So we're going to measure how far east that football stadium is from the closest grid line. So we're going to take our compass, we're going to hold it up to the map, we're going to measure the distance between this grid line to the football stadium. So when I put my compass up, I see around 10 millimeters. So 10 millimeters, and it's a ratio of 1 to 24,000. So I take 10, I multiply by 24, and I get to 240. So this easting would be 331,240. Now for the northing, now I'm going to measure the distance between the football stadium and the closest grid line. So now I'm seeing, let's say 20 millimeters. So 20 times 24 being 480. So that would make this 4317480. That would be the northing coordinate. So how far that location is north of the equator, and then how far the location is east of that beginning 18th zone. So that's our first example. Now, something else we want to do with our topo map is determine the angle, so our bearing between 2 points. So let's make an example of Lake Artemesia. So let's say I want to describe to someone how to get from the football stadium to Lake Artemesia. So there's a couple different ways I can do this using a topo map. The first thing I'm going to do is take my compass and dial in 0 degrees, so north, because with all topo maps, they're all aiming with north at the top. So I'm going to take my compass and I'm going to spin the dial so that north is aiming north. Then I'm going to place the compass on my screen, so on the digital map, and I will verify that all of the lines, all those little directionality lines that are parallel with the big, thick red north arrow, we want all those lines to be parallel, so the compass to be parallel with the digital map. Then I'm going to put the edge of the compass touching the football stadium. I'm going to spin the base plate so that the other edge is touching Lake Artemesia. So from here, I'm going to hold that on my screen. I'm going to take my reading. So to do that, I'm going to spin the dial so that 0 degrees or north is back to being north again. So that I want all those lines parallel again. I'll remove the compass from the screen, and now I take my reading, or my bearing. So I see 110 degrees. So the football stadium to Lake Artemesia is 110 degrees. Then I also want to tell someone how far to travel. So to do that, I again place my compass and I measure how many millimeters away, and I'm seeing right around 100 millimeters. 100 millimeters times 24 tells me how far away. And when I look at the map, this makes sense. It's a little over 2,000 meters, a little bit over 2 kilometers. And this does make sense because each one of these grid lines is exactly 1 kilometer away from the next grid line. And you can double check me by measuring it yourself. And you can measure this at any size that you've zoomed into this topo map, the ratio will always stay the same. So every time you take a measurement, you'll always see that it turns out to be 1 kilometer away. Each line is 1 kilometer away, or 1,000 meters. And when we look at our football stadium, it does indeed look like right around 2 full lines away. So it makes sense it's right around 2 kilometers. So that's how we would tell someone to dial. So starting at the football stadium, you would dial in 110 degrees and you would walk 2 kilometers in that direction to get between the two. Now, another thing we could do to double check this is I can put a compass on top of our football stadium, and I've made it somewhat transparent. So if I put that compass on top, and I do indeed see, I'm going to put the compass right on the middle of the football stadium, and indeed I see right around 110 degrees. So that's just a way to verify that we've measured this correctly. So that's how you use your topo maps. You're going to use it for determining your location or determining the location of a certain feature on the map, and then using your compass along with the map to determine your bearing and the distance you would need to travel between your 2 waypoints, so between your 2 locations. You'll also notice on the topo map the contour lines. So as they get more densely packed, that's indicating more rapid change in elevation. And you will be watching a separate video that explains how to interpret contour lines. But I hope you found this helpful and have fun practicing with your compass and the digital topo map. Next, I'll have video of how to use the printed topo